Hello students, welcome to today's lesson, our lesson 2, where we are going to discuss about detection of electromagnetic radiations. We start with radio waves. We have that these waves are subdivided into long waves, medium waves, and short waves. Now they are produced by oscillating electrical circuits, and these circuits can be controlled accurately. They are diffracted by small objects like houses and also large objects like hills. They are detected by resonant circuits, and these ones are found in radio receivers with diode and earphones. That is why you're able to detect a wave that is coming from Nairobi to your home and listen to that station. Then we have microwaves. They are produced by a special vacuum tubes called magnetrons, and these ones are found in microwave ovens. They are detected by crystal detectors, or what we call the solid state diode. Then next we have infrared. These ones, we have the ones that are very close to microwaves. These ones produce heat, and they are produced by sun, fire. But those that are close to the visible light, they do not produce heat. And a good example is TV remote control system. The main source of infrared is sun, fire, and hot objects. It is detected by human skin photographic film. That is why when you bask in the sun, you always feel the heat. That heat that you feel is what we call the infrared. Then from there we move to visible light. This one forms a very tiny part of electromagnetic spectrum, and it is produced by sun, electricity, and candles. Now, inside the visible light, what we call the white light, it can be subdivided into 7 colors, what we call the optical spectrum. We have red, orange, yellow, green, blue, indigo, and violet. These are the 7 colors of the rainbow. It is detected by our eyes because we are able to see. And photographic film, you are able to take photographs using the visible light and photocells. Then we have ultraviolet rays. These ones are produced by sun, welding machines that produce sparks, and mercury vapor lamp, and this is due to large energy changes in the electrons of atoms. Now, if you expose yourself to ultraviolet, you may cause, or it may cause, what we call the skin cancer. They are detected by photographic film, photocells, and paper smeared with Vaseline. We move to X-rays. They have a very short wavelength but a very high frequency, which implies that they possess a lot of energy, because we know that E, which is our energy, is HF. So if F is high, then our energy will also be high. They are produced by X-ray tubes, and this is where we have that a high-speed electron are stopped. And when they are stopped, their kinetic energy is converted to X-rays. Then we have that they are detected by photographic film and fluorescent screen, which implies that if you direct an X-ray on a fluorescent tube or a fluorescent screen, then that screen will glow and you will be able to see that there is a bright spot. Then we have gamma rays. They are produced by radioactive materials. Now, just to mention, radioactive materials occurs when we have that the number of neutrons and protons inside the nucleus of an atom are not equal. For example, if you take a case of sodium, it has 11 protons, 11 neutrons, and 11 electrons. But you may find that in some cases, you may find that those numbers are not equal. So when they are not equal, we say that that nucleus is unstable. And if it is unstable, it has to undergo some disintegration so that it can acquire stability. So that atom is what we call unstable. It has unstable nuclei. And when it undergoes disintegration, it releases some radiations. And that radiation is what we call gamma rays. So these ones are produced by radioactive materials when large changes of energy occurs inside their nucleus. They are detected by photographic film, or what we call the Geiger-Müller tube or a cloud chamber. From there, we move to applications of electromagnetic radiations. First, we have the radio waves. They are used in radio, TV, and cellular mobile phone in communication. They are also used in military communications, where we have the satellite imagery, and this forms an image of the ground even when there are crowds. So that way, they are able to get, the military, they are able to get information. Then we have microwaves. It is used in radar, that is in communication, and this gives us direction and distance. Also in speed guns or by the police to detect the overspeeding vehicles. In microwave ovens, they are used to warm food, and the food are warmed by absorbing the energy. Then they are also used for communication, that is in telephone and computer data. You can be able to see what we have in microwave oven. We have magnetron. This one produces microwaves. We have the metal stirrer, and where we have the rotating table, we have the control knob, and we have the wheel. So the food is placed on the rotating table, and when you connect it into our socket for the source of electricity, and then you put it on, you'll find that this one will rotate, and as it rotates, it will absorb heat or energy from these microwave waves, and therefore your food will get hot. From there, we have infrared. This one has a heating effect, and therefore it can be used in heating, cooking, and drying. They are also used to form infrared images of hot objects through the colors. So these images that are produced by satellites, they give important information on vegetation cover in a given area. They are also used in hospitals to detect illness. In warfare, we have what we call the heat-seeking missiles and the burglar alarm system. Also, they are used in greenhouses, and they help the plants to grow. What happens in the greenhouse is that it is covered with transparent glass, and this glass allows visible light, which has a short wavelength, to enter or to penetrate. Now, after penetrating, the plants and the living organism inside the greenhouse releases wavelength, or it releases an electromagnetic wave of longer wavelength, and that longer wavelength cannot be able to move out of the greenhouse through this transparent glass, and therefore it is trapped. That heat from the sun is trapped inside the greenhouse, and this makes the greenhouse warmer than the outside, thus providing a conducive environment for the plants to grow. From there, we have the visible light. This one will help the human beings in the identification of things. It is also used in taking the photographs, the ordinary photographs, and also in optical fibers. Now, optical fibers are used in communication. Now, it is also used in plants in the process of photosynthesis. Also in laser, what we call the light amplification by the stimulated emission of radiations. And these are beams. They are used in industries. For example, in timber industries, the laser beams are used to cut the timbers into desired sizes. Then we have ultraviolet. These ones, they can make, or they are used to make reflective materials which absorb light and re-emit it as visible light. And this is what we call spectroscopy. Also in bank, to detect fake currency. In medicine, it is used to kill bacteria, or in skin treatment, and also it is a source of vitamin D. That is why it is very important for you to bask in the sun, for you to get this vitamin D to boost your immunity. In mineral analysis, and also in washing powder, they are mixed with washing powder to make the clean clothes look brighter. Then we have X-rays. They are used in hospitals to detect the fractures or broken bones, and also in treatment of cancer, what we call the radiotherapy. They are also used to detect foreign materials in the body. For example, if you swallow metallic substance like a coin, you can be able to use X-rays to detect where that material is. They are also used in industries to detect invisible cracks in metals and also in welding joints. In pests, it can kill pests and germs. In the study of crystals, what we call the crystallography, we can use the X-rays to see the arrangement of the atoms. Then from there, we have the gamma rays. They are used in medicines to locate internal body organs, also to sterilize surgical instruments because it can kill germs. It can also be used to kill cancerous cells. So if gamma rays is directed to where you have the cancer, those cells can be killed with gamma rays or any other growth in your body. In industries, it is used to detect the flaws in metals. It can kill weevils in grains and also take photographs the same way like X-rays. Now we have some hazards or problems that are created by these electromagnetic waves, which implies that when you expose yourself to UV, that is ultraviolet, X-rays and gamma rays, you have a risk of getting cancer because they possess a lot of energy. So if this energy is absorbed by your body in large amounts, then it can damage the cells, it can cause skin burns or affect your eyes. So it is important to avoid longer exposure of these radiations. And these effects are also the delayed effect of radiations as cancer, leukemia, and hereditary effects in children. How do we minimize these hazards? One, we reduce dosage by minimizing the exposure time. Ensure that even if you are working in an industry that produces these radiations, make sure that you work for a short time. Then keep a safe distance from the radiations. Then use shielding materials like lead jackets. Now what will happen is that when you use the lead jacket, it is going to absorb the radiations. That way they will prevent, or that the radiations will be prevented from reaching your body. That way you are safe. From there, we move to problems involving C is equals to lambda frequency. We start with the first example. Calculate the wavelength of KBC radio waves transmitted at a frequency of 95.7 megahertz. We start with the formula, then we substitute. This C is representing the speed of wave. Then we have F is representing the frequency of the wave. Then put these terms inside the brackets in your calculator. And then when you key in, you'll find that your wavelength will be 3.13 meters. Then question number 2, light of wavelength 6.7 times 10 to the power negative 7 meters has a frequency of 4.48 times 10 to the power 14 hertz. Calculate its speed. We start with the formula C is equals to lambda frequency. Then we substitute our values. C, our lambda is this one, is given, that is wavelength 6.7 times 10 to the power negative 7 meters. Then we have the frequency as 4.48 times 10 to the power 14 per second. When you multiply, you get that your speed will be 3.002 times 10 to the power 8 meters per second. Then the third example, calculate the wavelength of green light whose energy is this one. We proceed as follows. Our energy is equal to HF. Remember, we are supposed to get the wavelength. But first of all, we can be able to know that F is equal to C over lambda. So replacing, where we have F, we replace with the C over lambda. You'll get that energy is HC over lambda. From there, we make lambda the subject of the formula. Lambda will be HC over A. After that, we substitute. We have H as our Planck's constant, we have C as the speed of light, and we have E as the energy. So when you substitute and you key in, making sure that you put the bracket on each value, then you will get that the wavelength will be 5.875 meters. From there, we have the assignments. The assignments are just testing what we have just learned or what we have just discussed. So make sure that you revise, you comprehend everything before you come to the assignment. So thank you and welcome to end of topic exam. Let us meet in another topic.